Hi guys. So in this quick recording, right, I'm going to share you guys some insight about how you can work on the Hive additional use cases. So I mean, like I'm planning to update something over here based on the activity what I perform. However, you can maybe like walk over with this video to do this exercise more efficiently. Okay. So the additional use case exercise. So here we are going to mainly concentrate on learning about how to do schema migration. Schema migration is nothing but the concept of converting the data from one form to another form or migrating the schema of maybe like CSV to JSON or JSON to CSV or CSV to Avro or Avro to CSV, something like that. We are going to migrate the data from one form to another form. We are going to learn about some sort of SERDs which we did not cover in our regular exercise, like something called specifically called the CSV SERD, comma separated value, serialization, deserialization operation we are going to do for some special cases that we are going to cover here, and some sort of JSON related data we are going to handle, and one type of data called fixed with data, which we did not discuss anywhere in our discussion. We are going to cover that scenario also over here, plus some scoop, import, export, additional features and all we are going to cover, options and all we are going to cover. On top of that, the DML operation we are going to see, which is where Hive is not meant for doing DML or ACID operations, the atomicity, consistency, integrity, durability operations, but still we can able to perform the data manipulation language like insert, update, delete, or even the ACID transactions like you can call it as an insert, update, delete on an atomic fashion, on an individual record by record fashion. And then we are going to learn about some ETL and ELT operation that we can perform end to end. So if we know about all these data engineering practices, right, data management techniques, we can we can call ourselves as we are one among the very few know about these concepts and all. Okay, these interesting advanced concepts. So let's go and first create one folder where we can go and keep all our use case related contents. Okay, so I'm just going to our VM. I'm checking the run jar is running. So I can consider all my Hadoop daemons are running and the run jar is also running, which I have started by issuing hive-service metastore. So if you see here, already I have started this service called hive-service metastore ampersand. Because of that service is running, I could boldly say like I can just go ahead with the starting of the Hive prompt. So I'm going to start the Hive prompt over here. You can start even beeline prompt also, whichever is fine. And parallelly, I'm going to open the or going to our other terminal where I'm going to create a directory for keeping all the use cases related stuffs, the data related to the use cases, what we are going to do. We have something called Hive use case directory, which does not contain anything. Now what we are going to do is, we can go to our Inceptor site, right? In the inceptors.in, we can go and maybe like get some of the data downloaded, which we are going to use it for our iterations, for our whatever the maybe the use cases that we are going to do. So go to inceptors.in, you can go all the way down, or you can go to the more page, you can go to view all. Here we can go to the next page by clicking the page down. You can see something called the Hive additional use case or whatever. Hive real-time use case for interview preparation like this. I have one page created. In this page, you guys can go and download the data for our use cases. So click on this data. You can get some data downloaded, the payments and the customer original.sql content. So let us get this downloaded. Maybe Hive use cases related content what I have here. You can download this. So let's download this content into our into our Windows platform. We can take this data further for our use cases. Maybe let me download this in our Hive location. somewhere here in the Hive use cases for students location. I'm going to paste this, keep this. So by this way, we could able to maybe get the data that is required. So let me extract it, and I'll take this data inside our whatever the folder that we created in the VM, right? So there is one folder called Hive use case I created in the home HT user directory. I'm going to keep this content in the use case folder like this, something like this. Now we got the data ready. So we are good to go ahead with the use cases, what we are trying to achieve. So ensure the Hadoop daemons, MySQL, Hive Metastore are all running, right? So we can ensure by using JPS, we can ensure by using maybe Hive service or JPS, and then MySQL-U, root-P, right? The password can be typed as root123$, then Hive-service, Metastore, ampersand. By this way, I'm starting all the services for your reference. Okay, fine. Let's go ahead further. So this is the first use case we are going to try. The use case number one is, can we do, this is an interview question predominantly asked, can we do the DML operations in Hive or not? That is the first question, what can be asked. Or can you do an ACID operation on the Hive tables? The answer for that is, by default, it is not possible, but we can able to uh, do the ACID transactions in Hive by creating the Hive in a special format, the table in a special format, okay? Like this, we are going to learn about this concept for predominantly, or maybe like secondarily. Before that, we are going to understand about how do we do ETL and ELT operation with Hive, right? That is one more concept we are going to learn in the first use case, and we are going to learn about something called benchmarking in Hive. How do we do benchmarking of different data sets and capture that benchmarked result to understand which data set seems to be more better for what sort of use cases? Okay, so let's try to first of all understand how do we perform ETL and ELT operation. Maybe this is the first operation we are going to perform as a first part. Then we will be doing the DML or ACID operations and all in Hive. So Hive can do ETL and ELT operation very efficiently. So how do we see, or how do we apply some business logics, some strategies and all to load the data across multiple tables like staging or a kind of a raw tables? And how do we create some denormalized tables? Denormalized means the flattened table by applying some joins or doing some sort of concatenation of fields, doing the summation of fields or aggregation of fields, and how do we write some analytical queries on top of this data. So all this can be done on the layers of maybe like curated layers or discovery layer. In these layers, we can perform all these operations. So how we can do these operations, let's try to understand. So predominantly, we are going to get the raw data in a form of file, or from a table, we are going to scoop it. We are going to keep it, load it into the Hive table, right, as is. And we are going to apply the ETL transformation. Maybe here we are doing an EL operation, extract and load operation. Then we are going to do the transformation operation, such as join, doing some sort of conversion of data. That is nothing but the schema migration, or merging of data, or derivation of some additional fields. Then we are going to enable the data for analysis, which will be done in the discovery layer. So these are all the curated layer. So in the raw layer, we'll be loading the data in the Hive tables. Then we apply in the curated layer, we will be transforming, applying the ETL operations or ELT operations as well. Then the data will be ready for analysis, which can be considered as a discovery layer. So we are building different layers in our data lake in a form of lake houses, right? So now let's see the data ingestion layer or data ingestion feature, right? Which will be done between the transient layer and the raw layer. So transient to raw layer. we are going to cover here in this data ingestion state. So first we have to ingest the data from the source to our maybe like Hive table or whatever. So for that, what we are going to do, first we create a database, something called customer DB, right? And we are going to go to the database. We are going to create one table called customer. We are going to load the data that is present in our Hive location. In this location, everybody will have this data already present. I have provided the VM with all this data available. So you can go and issue on this data. You can see some data set available in this location. So customer ID, first name, last name, age, and the profession of the customer. So this data we can do some sort of operation of loading it into the table. So this is the first time this data we are seeing, which you can consider as a data set for our use cases. So we are creating a table, managed table, loading the data into that managed table by using the load command, merely considering the data is available in our Linux file system. So the data is getting stored in the Linux file system, which is the transient layer. We are going to load the data into our raw layer. So let's go and create a database called custdb. This custdb is a raw layer database. So we are going to execute this operation. Maybe the custdb might be already present, so we don't have to worry about maybe getting it tried. We can mention something called create database if not exist class to avoid the error what we are getting here, right? However, we are getting this table created and loaded with the data. So we have the customer table available. Okay, fine. So we got the data loaded into this customer table, but we have one problem here. The column header seems to be also loaded, or we don't have the column header, but the table column name is shown as a header over here. So in this data, we don't have the header. So we don't have to worry about that part. Cust file we loaded, right? So we don't have any header. So automatically the data got loaded into the respective field of the respective table, right? Into the respective one-to-one mapping, or our positional mapping has been happened over here in this customer table. Okay. So now we have completed the raw data load or raw layer data load in the form of the customer table inside the custdb database. Now we are going to apply some sort of curation operation in the curated layer, or from the raw to curated layer, we are going to load the data. Okay, create a customer transaction table and load the customer and the transaction data by joining these two tables located in multiple databases such as the retail database and the custdb database. So this will give you an idea of understanding or answering a question of can we join or can we do an operation between two tables that is residing in two different databases? The answer is yes, we can do. How we can do that? By prefixing the database name dot table name, right? By prefixing the schema name or the database name, we can able to achieve that. That is a key concept here. And we are going to create one table called customer transaction table. That customer transaction table is technically called as denormalized table. So we are creating a denormalized table. We have the separate table called customer available, and we have a separate table called transaction available, which we created long ago. In this retail database, in our regular use case of Hive, we already have created a table called retail.transactions. So if we go and see this table, you have this table already created as a part of our Hive use cases what we performed, or Hive hands-on exercise what we performed. Since this table is not present, maybe I might have dropped the table. Let's go and create it very quickly. So I'm going to install folder or IZ workouts folder where we have the Hive document available. Maybe like the Hive workouts document that is available. I'm going to first create a table called transaction records, TXN records table, which we used to create in the first part of our learning. over here. Before partitioning and all, we used to create this table and load the data in the retail database, if you see here. So we go to the retail database and we create this table and load the data as well. You can consider this operation also as our the raw table load, right? Use retail. Since we already had it in our document, I am not again mentioning this in our use case document, but if you want, you can go and get this added here as well. Like before doing this, we can say, maybe go to the retail DB, get this table created. So we are getting this table created over here in this retail database, right? Okay. So two tables we got created and we are going to load the data into this table as well. Creation alone is not enough. So let me load the data from the Linux file system or from the Hadoop file system, doesn't matter. Okay. So let's load the data from these tables, from the file system to this table as well. So now we are going to join the data between the customer DB and the retail DB. And we are going to keep the data into a new table called ext customer txn part or something like that, which we can create it in a curated database, something like create database name as curated zone or curated DB, something like this I'm creating. So in the curated DB, we are going to keep this table created, and I'm creating this table as an external table, right? Maybe in order to make this table more performant, what we can do, we can mention or we can create this table in a format of ORC or packet. Why I did not do this in our use case predominantly is we are going to talk about the ORC packet and all this kind of maybe the table, the data type and all, or the file type and all in the subsequent discussion. But however, to make it more meaningful, to make it more performant, I'm going to add maybe stored as ORC. So this will be more efficient in terms of managing the data. So TXN, custom TXN ORC, like this I'm creating the folder in the underlying location of the external table. So this table is a denormalized table. ext customer transaction part denormalized table you can mention, or let it be as the same name, but this table is generally called as a denormalized table. So I'm creating a database called curated DB. That curated DB, I'm creating a table called use curated DB. And inside this curated DB, I'm creating one table called customer, ext customer transaction part, which is of type ORC type. I'm going to do an insert into this table, right? By doing a dynamic partitioning, right? By selecting the data from the customer table and the transaction table, which we got created in the earlier use cases, right? So this TXN records we just got created. Customer table also we got created in the CustoDB database. And we are going to perform a join operation between these two tables, right? To create a denormalized data of, or to create or to load the data into the denormalized table, which is partitioned dynamically by using the data date that we have in the whatever maybe the transaction records table contains the data date as a column. So we are going to take the data date column the data date column from the table we are not taking. We are going to derive the data date column from the current environment. So I'm going to use the current date function. If you see here, it will show me the current date of our system. So it is showing 2023-04-14 is the current date. You can see here. So that date it is showing as a current date. So I'm going to take that date as a partition data date column or partition data date value, and I'm going to load the data into this table. So what happens every day when you load the data into this table by pulling the data from the customer in the transaction records table, which is going to have the daily data, it will be loaded with the current date as a partition value for this target table of the TX and PART table. Okay, so now we are going to load the data into this table, which comprised of customer number, full name, whereas the first name and last name we are receiving from the source in the customer table, but we are going to concatenate them. So we are applying some function called concatenate function, upper function, and putting the data together in a column. Then we are taking the age field, profession field, amount field, and then the product field, and we are bringing the spend by field also from the B table, which is nothing but the transaction table, and we are having a derived column created here. So why I'm showing this use case is to show you guys we are doing some sort of merging of fields, we are doing some derivation of fields. These are all the terminologies used in the data engineering world. So if you are very new to the data engineering, or if you are very new to the database world even, these are all some of the terminologies used in the database and in the data warehouses environments. So when we do ETL or ELT operations, we apply all this transformation logic, or we apply this kind of maybe like derivation logic. We are going to create derived columns here. So the age category is a derived column. We are deriving based on the case statement that we use. It's like an if condition. If age is less than 30, then make it as low. The value for the age category is low. If it is in a range of 30 to 50, then you can make it as middle. If it is greater than or equal to 50, then make it as old. Something like this. I'm creating a derived column here. So this is a kind of a merged field or transformed field, you call it as. Here you can call this as a derived field. And we are creating one more derived field as modified amount, which is where we are applying some maybe like surcharges for the credit card the customer have used. Whichever the customer used a credit card for transaction, the spend by column, I'm going to check if it is credit card transaction means then I'm charging 5% additionally for the credit card transaction. If no credit cards are used, then I'm charging it as just an amount itself, and I'm going to load this data into our target table. So I'm doing a kind of a curation operation here. We call this as a curation. We call this entire concept as a curation operation we are doing. So what it is telling, dynamic partition is not allowed. So I have to set this to allow the dynamic partition by making it as non-strict. Originally it was in a strict mode. By default it will be in the strict mode. After this I can able to load the data into the denormalized table called, or denormalized dynamically partitioned ORC based table called ext cust tx and part table. Now we got the data loaded in this table, which is in ORC format internally, but externally when I get the data from this table, it will show as a normal output because it uses the it uses the ORC SERD or ORC deserializer to produce the output. So the output format will be ORC output format. Using that, it will show me the output in a normal format of text. So by this way, we completed the curation or curated layer load. Then we are going to enable the data for visualization or for analytics or for aggregation further or for reporting or in the discovery layer. So we are going to load the data into the discovery layer. So from curated to discovery, we are going to load the data respectively. So we are going to create an aggregated table, right? That will be considered as the derived table or a kind of a KPI table. We call it as a KPI as key performance indicator. So this you can call out in the interview or anywhere saying like, hey, in my project, what I do, I get the raw data, load it into the raw layer. Then from the transient layer, I'll be loading into raw layer. From raw to curated layer, I'll apply some joins or derived column creation or conversion or maybe like merging of fields. All this I'll do. Then I'll do what? I'll be loading the data into the aggregated table, or I'll be getting the data ready for reporting, or I'll do some sort of aggregation on the data, grouping and aggregation. Or I'll do what? I'll build or I'll derive the key performance indicators, or I'll create the cubes for producing the output in a multi-dimensional view. So you know about the cube which has 6 faces, right? In each and every side, if you see the cube, you'll be seeing the different faces of cube. The data can also be seen in different faces. That means what? if you look at this data set, we are seeing the data aggregated based on the product, profession, age category, and the current date. Here we are seeing the data is grouped based on profession, age category, and the current date. It is not grouped based on the product. So this table where I'm going to create as an aggregate number 1 is going to show one face of the cube. The another face of the cube can be seen as aggregate number 2. Like this, we can create multiple faces of the cube. We call this concept as a cube creation. All these are the concepts what will be used in the market. We create the tables, or the cube tables like this. It may be asked, or create the KPI tables like it may be asked, or derive some metrics out of the data, may be asked as a question in the organizations, or we just needed some data for quick reporting because already we are having this data aggregated, right? The aggregated data will be ready for generating the report. Just like that, all I have to do is what? Not writing all this query and waiting for the result. All I have to just do is take the data from this table once it is been created. So what I'm going to do here, let's create a layer called, a database called maybe discovery DB. Like this, I'm creating one database. And this table also possibly can be created as external table with stored as ORC or PART or whatever, right? And this comparison we'll do later. Which one is going to occupy lesser space, or which one is going to perform more better? Based on that, we can decide on going with ORC or PART or any other type of data that we can use, right? We can mention the location also over here for making the external table more meaningful. But we can create an external table without location also, what we are all aware of. So let's go and create this table by mentioning these features. So location is first trans aggregate number 1. This aggregate number 1 table is going to do what? Maybe hold the data which is aggregated, which is maybe like applied with some sort of aggregation function such as the sum of amount, average amount, max amount, average age. All these are the aggregate functions that I'm applying: max, min, average, sum, and all. And I'm going to derive a sequence number column also, where we use a function called row number of over function to derive some sequence number column. For example, I want to create the number column starting from 1, 2, 3, 4 like that for every run. For a given date, I need the data like this, something like this. I'll show you guys how the data looks like after we execute. Then you'll understand what is this row number of over, which is an analytical function. We have to learn about this row number, rank, dense rank, percentile, like such concepts are available, which we call those concepts as windowing functions or analytical functions that we learn more in detail in our interview discussion and all. But however, this could be the first cut understanding for all you guys to understand about what is maybe like how do we apply some analytical function to create some sequence number, some running number starting from 1 to what are the number of records that we have for a given date. That means number of sequence number will be created in this table as a part of execution. So let's go and see that. But before that, let's go and check the data is loaded in the table or not, the curated table, right? It should have the flattened data. So this table contains, the external table contains you can see the derived column got created. The age category is shown as old age category, middle age category, and the amount, original amount is $40. Since the credit card has been used, the amount has been modified or maybe like increased to 42 point odd dollars. But if I use cash, the amount spent is $5.95, and the same amount is mentioned here as well in the derived, in the maybe modified amount also. And the name of the customer is made as a single full name. So these are all some derivation we did, and we have the data in a denormalized fashion. Directly we can go and fetch the data without joining the tables from this table very easily. That's the reason we are creating a denominalized table, which we use. This denominalized table we use further in our maybe like next level. That is nothing but the creation of the aggregation table in the discovery layer, right? We'll use this as a source table. So we are going to create an external table which is supposed to be aggregated based on couple of columns, right? The sum of amount, average amount, everything has to be created and stored into the respective fields based on certain grouping columns such as the product column, profession column, or age category column, and the date column. Based on all this column, the data will be grouped and stored into this customer aggregate table. Let's go and see how this is working. We'll just try to create this database table and everything and achieve that. So I want to use this discovery DB to go and create this table and load the data. Let's do that operation. Let it complete. We'll go and discuss about this part. So what it is telling, something like ext cust txn part table not found. Why? Because the table is present in the curated layer, curated DB. So I have to either prefix here as curated DB dot. So by that way, I can load this data. And parallelly, I'm going to load the data into one another table, which is almost having the same kind of properties like ORC table with maybe for a change we'll create parquet table here rather than ORC table for the aggregate number 2. So parquet will create, which is having an optimized data set, right? In a column oriented fashion, it stores the data, and the performance of getting this data retrieved back or aggregated or maybe like report generated as a report and all will be much faster. So we are going to create one more table, aggregate 2 parquet, and we are going to load the data into the table by doing some sort of other level of aggregation. So why we are doing this aggregation priorly? So the consumer can consume this aggregated data directly by writing a normal query. They don't have to wait for this much time to perform all this aggregation on a very large volume of data. The idea behind why we have the discover layer or a reporting layer created is at the time when the customer builds the report or at the time the customer accesses the report, they don't have to go and write all these queries and all. All they have to do is what? Just to do a select start from this table name. All they have to do is just select the data from this table, which will return the aggregated result directly to them. The aggregate table number 1 or 2, whatever the way you want to aggregate, you can aggregate based on product wise, profession wise, age category wise, date wise, you want to aggregate, you can aggregate. And this table will have this running number in the first column. That is a sequence number in the first column. So let's see the data. You can see the sequence number of 1, 2, 3, 4, all it is showing. And it is showing the data which is being aggregated based on the maybe like product is rustling, and the profession of the customer is a writer. So in the rustling product by the writer of old age group have purchased and an average of this much amount, or for a sum of amount of this much, and maybe like some sum of amount, average of amount, or the max amount, or average age of the people on a given date. This much transaction have happened in a cumulative fashion, maybe in an aggregated fashion. We call this as an KPIs, key performance indicator. What is the max amount? What is the average age? What is the average amount? What is the sum amount? These are all the concept of creating the KPIs, key performance indicators. So this is one table got created. In the same way, we can create the other table also and get the data loaded. By this way, we are generating different set of aggregated tables. So whichever the customer or whoever the customer wanted to see the data at the profession level, age category level, and a given date level, they will go and see the data. Whoever wanted to see the data at the profession level or at the product level, then the profession level, they want to go one level lower and see the product level, the profession level, the age category level, what is the sum of amount, max amount, min amount and all. But only at the level of maybe profession, age category, and the date alone. If I want to see the data, still I can generate the another type of reporting table, which will act like one another face of a cube. So like I can say, aggregate table number one is a cubes one side. Aggregate table number two is the cubes another side. We can call it as a cubes also. What we can name it in our data warehouse or in the big data engineering terminology. So we are done with creating some tables which can be exposed to the outside world for a quick reporting or consumption or deriving some KPI or metrics purpose in the organization. So we are creating something called a surrogate key, which is nothing but a dummy running number we are creating using a OLAP function or an analytical function or a windowing function. We can call it in any name, analytical function or windowing function. We'll learn about this windowing, analytical, and OLAP functions and all more in detail in a later point of time. So using multiple dimensions such as product, profession, age category, and the date dimension, we are going to generate the output in one table. And we are using different set of dimensions. In different dimension, we are seeing the output, such as profession, age category, and the date. We are seeing we are aggregating the data as well. So based on different dimensions, we can aggregate the data. That is the concept behind this one. Okay. So we got the two tables created, and this is the end of the use case number 1.1. Now let's go and see about the next use case. It's all about how do we perform DML operations in Hive, right? Basically, if I have a customer table which we got created in the previous use case, right? Maybe I'll go back to CustDB. We have a table called customer table. This customer table, if I wanted to update, so I'm going to write an update statement as like I have mentioned here. Update table name set profession equal to IT, where customer number equal to 4,000,001, right? I'm going to update. Here what it is telling, normally an update or delete could not be possible because the given transaction manager that we have used in this current environment will not support that. And in order to do a DML operation in a table, you have to make the table or create the table in a special fashion like this and all. It is putting a lot of constraints for me to do an update operation or a delete operation. Both are normally not supported in a Hive environment. That is the thumb rule what we have. So in order to make this supported, we have to create a special type of table called transactional table with buckets and with a format of ORC has to be created. So all this has to be applied in a table to make it operative in a DML fashion. We want to do DML or ACID transaction on a table. We have to obviously create a table with buckets. Maybe any number of buckets is fine. Maybe you can use maybe 3 to 10 buckets in numbers on a particular column. Any one of the particular column doesn't matter. You have to create a buckets basically for a performance reason. Internally, Hive is asking us to create the bucketed table, and the data must be stored in a ORC format. Otherwise, it won't support the DML operation. And we have to make the tables one of the property, the table property as transactional true. Then only it will be started supporting the DML operations on the table. And apart from that, we have to set the environment to support the concurrency. So by default, maybe the concurrency might be set to either true or false. So it is set to false by default. So concurrently, if you want to update this table or insert this table from different user side or from the different session in Hive, that will lead to a locking of table. So we are going to use two properties to avoid locking of table, something like a concurrency property and the transaction manager property. If you do transaction operation on the Hive table, it has to be managed by this Java program internally. So we are going to set these two properties on top of our Hive environment to enable DML operations on the table. So we are doing all these operations before we perform DML. So now the table got created, which is ready for applying the update or delete or whatever, right? We are going to load some data to this DML table, first of all, to understand like how to perform some sort of DML operations in this table. This table does not have any data, so I'm inserting some data to this table for an understanding purpose. One thing you have to notice very clearly is the data in this custDML table will be loaded into the underlying storage of 3 files, right? So in the custody location, we can see user Hive warehouse custody.db slash this table name, customer DML table. Inside this, you can find almost 3, whatever the bucket files or clustered files will be created. So the understanding here is we'll be seeing 3 folders got created, under which we'll be having the files are created. I mean, in a single folder, we got 3 files created, right? In general. So let it complete. We can see this location will have some folders got, some files got created under the folder. Let's go and see that part. Now, if we go and perform some insert operation, or not insert operation, update operation, what happens, the data that is present in this folder will be untouched basically. So this is the concept what Hive uses in the background. Maybe let me check what is the table is pointing to, where this table. How can I check? Describe formatted table name is going to give me where this table is locating. Custody dot user HDuser custody.dml custody slash custody.dml in the user HDuser itself. I hope like we created this database in this location by mentioning the database location option. So you can see there is a folder with 3 files created inside it, which we call it as a delta folder. Automatically it will internally create the folder name called delta. What is delta means? We'll go and see. You can see 3 files are kept inside, right? So this 3 files inside this delta folder is having almost the 10,000 records that is present in the customer table. The entire data is stored across 3 buckets, 3 bucketed files, usually by using the concept of bucketing. Now I'm going to do what? I'm going to perform an operation of update. Right after I completed the insert, I'm going to just select the data from the table to understand what is the original data in this table is available. So it's showing me the original customer's profession is pilot. Now I'm going to do what? I'm going to update the profession from pilot to IT or something else, right? For the given customer. What is supposed to happen? This data has to be updated. But you see how long it is taking for updating, right? That is a longer time. So we should not encourage doing updates on the Hive tables. But if we want to still really achieve that, we can just apply this update statements or delete statements also. It works, but it is a costly approach what it will take care in the background. What it will do is basically, it won't go and touch the data in any of these buckets. Rather, what it will do, it will go and create the data in one more folder. It will just do keep the updated data in one more folder, that is delta number 2 or delta number 3, like that it will keep. By that way, the original data which is not yet updated, right, which is kept in the Hadoop file system, will remains there as is. It won't touch the original data. See, basically this customer number 4,000,001 modulo of 3, right, will go into maybe like any one of this bucket. Okay, 4,000,001 divided by 3 will be returning some number like maybe let's say 40 divided by 3, 39, 1, 2. So in the bucket number 2, hopefully this data might be kept by default. Okay, we can't able to see the data because it is in a ORC file format. Directly we can't see this. Let it be. Let's assume the data is kept. It's 4,000,001 customers data is kept in the particular file called bucket number 2. Let's assume in that way. Now, after I update, what happens? If you think the data in this particular bucket got updated, means that is wrong. What it will do, rather, it will go and create one more new delta folder and keep that updated data alone in that new Delta folder. If you go and see here, you can understand. So in this cust DML location, you'll see one more folder called Delta number 2 will be created. Are you seeing the Delta number 2 got created? That says what, Irfan? Originally, whatever you updated at 118, right, 118 AM, I did not touch any of this data. You wanted me to update, I did not update it really. Rather, what I did is I created a new folder, new Delta folder, and what I did is I just kept this data in a new folder as updated one. So what happened in the background is Hive told what you know, Irfan, I'll retain the original data in first folder, that is the Delta folder number 1. I'll be maintaining the original data in bucket number 2. And if you ask me to update or delete, I will do the update or delete operation and keep that deleted or updated data in the Delta number 2 in a different folder. I don't affect the existing data because Hadoop will not naturally allow me to do the update operation or delete operation on the data. So I still follow the Hadoop's rule. But what I will do, I'll keep the updated data in a different folder. Then later you can merge this folder number 1, folder number 2 and all into a single folder by applying some concept of compaction. Okay, there is a concept called compaction that will be taken care by the administrators. We don't have to worry, but however, what I will say, I'll keep the updated data in a different folder, Delta folder, in a different file, something like a bucket 0 or 1 or 2, any one of the file, I'll keep the data. And I don't touch the original data, whatever having the pilot as a data originally. So the IT data will be stored here. The IT profession data of the given customer is stored here in the bucket number maybe 0. Maybe this 4 lakh one is applicable for bucket number 0, let's assume. Okay. So what will happen? This bucket number 0 will hold only that particular data set of whatever that new profession that we got achieved, that we got updated. So the updated data is kept here. The original data of our customer will be kept in the other file. So in the other Delta folder number 1, which will not be affected at all. So this data set you can see something like IT. You can see the data got updated as IT here. But whereas in the other hand, if you go and see in the original file, so let's go and search for the Christina in that original file. I'm going to search for this Christina in the bucket number or the Delta file number 1, which will be non-affected, which will be still there as pilot only. You can see this Krishna will still show as a pilot only in the original data. Maybe I think it will be kept in the bucket number, the different bucket maybe. I don't bother. Maybe since the data is in a kind of ORC format, I'm not able to, this grep is not running on top of it, let it be. However, what we can consider is the updated data will be kept in a separate folder, something called maybe like Delta folder, and the original data will be kept in a old Delta folder. In the Delta folder number 1, the original data will be kept in a form of buckets, and in the the updated data will be kept in the new Delta folder. Like this, the Hive will do what? It won't affect the actual data. It will go and create the Delta data for us whenever we do update or delete. It is a costly operation only, but there is no other way. This is how Hive works. If I go and delete also, the same thing will happen. It will create one more Delta folder called Delta folder number 3. However, I achieve the result. If you go and see, we can see the data shows it got updated. You can see now, we can see IT as a result. Where it gets this IT value from? From the second Delta folder, which will override. So though we have Christina Chung with a profession as pilot and IT, it will show the recent value by taking the recent Delta folder file, not the old Delta folder file. So now I'm going to update, perform an delete operation. What happens? the 4000 or 4,000,002 will be deleted and kept in a new delta folder called delta folder number 3 with some bucket value created. That bucket will hold the delete marker, deleted information of the data. By that way, it will say, Irfan, sorry, this data is lost. If you go on query, it will show no data found. But however, this 4,000,002 will be present in the original bucket what we created. That is bucket number, that is in the delta number 1, right? Delta folder number 1. This will be still kept. So that is the key concept of performing DML operation. So the answer for the question is, we don't have to think about all these delta folders or everything. All we have to understand is what? Hey, if you the interview question will be like this. Hey, can you or the DML is supported in Hive? Like this, they may be asking. You can say, yes, it is supported, but not by default. We have to create the table bucketed, or we have to make the table type as ORC, stored as ORC, or the transactional property we have to set as true, and some more properties we have to set like concurrency or DB transaction manager. Some properties we have to set. I don't exactly remember like this. You can say, after you do all these preliminary things, then you can update or delete the data from a table as well, but which is a very costly operation to perform, which is not suggested. But still, we can go and do that operation like this. You are going to answer. So when this data in this underlying folder will be clubbed together, will be merged together, when I perform the operation of something called, so if I go and see this data, you have to do an operation of something called compaction, major compaction. At the time, the data in the different delta folder will be merged together into a single data set. By that way, in front of you, the Hive will not do the real update or delete of the data from the actual data set. Rather, by the end of the day, my administrator will go and run this major compaction function or a query to initiate the compaction in the background. And that will be running as a program in the background in a later point of time. So we'll see this data will be gathered together. Now you see there is a variation that will be applied on this data. Maybe not immediately it is applying. We have to run it as a program to get this achieved. So now just alter alone is not enough. We have to apply major compact true and all as a property. So let's not worry about this compaction operation, but it's an operation which will be done by our administrator in an off-peak time. Off-peak time means this cluster is not so busy. At the time, they'll do this operation to club all these underlying files, delta folder files into the single data set. Okay, this is altogether about the DML operation in Hive. And the benchmarking of different types of file format in Hive. What is benchmarking? Basically, we are going to measure the performance between different types of maybe the file format or different types of options when we use, how the performance is going to be. Here we are going to create the data of text file, ORC, Avro, Parquet and all, and we are going to test or check or benchmark the performance between all the tables in terms of the size, how much it occupied, or in terms of how long it is taking to run the queries, right? All this. Check or benchmark, like this you can call. So you can create a table in a text file format. I think this one we already discussed in our regular discussion of Hive. However, you can consider this over here. First, we are creating the table as a text file table. Loading the data into the text file table is directly possible using the normal load data local in path command. But we are going to store the same data into a Parquet file. For that, what you are supposed to do, we have to use this staging table what we created, right? Which is of normal text type, and we are converting. This is called schema migration. So we are doing the schema migration as well. That means from text to Parquet or ORC or Avro. Like this, we can convert. We can take the data from the Parquet and convert to Avro. We can take the data from ORC and convert to Parquet. Like anything we can do. So by this way, mentioning the stored as Parquet file, we could be able to store the data in a Parquet file format into this table, ORC file format into this table, and Avro file format in this table by maybe modifying or just downloading the Avro's recent maybe the library file from the internet, because whatever the current Avro file that we kept or we have it in our Hadoop's library will not be fulfilling our requirement. We have some problem basically. So we are removing the Hadoop common libraries Avro file. We are pulling the 1.8.2 version from the internet, downloading that Avro file from the internet, going into this URL, and we are replacing that. We are keeping it in the downloads location or somewhere, replacing our or removing and maybe like keeping our new version 1.8.2 Avro version in this location. Then we are going with the Avro table creation. Then we are loading the data into the Avro table, and what we are doing, we are running some queries on top of all these type of tables, text table, ORC table, Parquet table and all, and seeing like how long it is taking to run the queries of what we have above, and how much data it is occupied in the underlying Hadoop folder. We are going to see and find what is the size the Avro is occupying, text file is occupying, ORC is occupying, and Parquet is occupying, and we are going to put that benchmarked output in this tabular column for our referential purpose, right? This is one another use case what we are supposed to know. Okay, so let me go with the second use case. So in the first use case, we had three use cases, such as one is ETL ELT operations, then second one is DML operation, the third one is benchmarking of or we can call it as a schema migration or benchmarking of different file formats. Then we are going with the second use case called CSV SERDI. So we know about there are different types of SERDIs are available: ORC, Parquet, or Avro, or RC, or sequence file, JSON, or such kind of serialization, deserialization features, or lazy simple SERDI kind of features and all, what Hive supports basically. Apart from that, Hive supports two more type of SERDIs, such as regular expression SERDI or CSV SERDI also. Here we are seeing the CSV SERDI. Regular expression SERDI, you will be seeing it in the project that I have shared you guys. Okay, so the CSV SERDI is all about, we can handle the data which is a normal comma separated value, right? Which can have some special type of data in it. Special type means, take a literal example. If you are going to get the data from the source database or from the file, which contains the comma separated value or a pipe delimited value or whatever, right? But what is going to happen here, the data itself in the table may contain, the column value may contain the delimiter value also. For example, let's take an address. If you have the data like this, right? For example, I have a customer ID, customer name, right? And the address of the customer. That is nothing but it is in the address of maybe something like this. 1 second. So ID, name of the customer, and address, and the maybe like what to say, the city, not the city, maybe area, like this I'm having. So if I go and keep the data like this, address as number 27A Brahmin Street, Velachery, like this, if I have, right, not area, let's consider it as a city column we have. Then I'm going to keep city as Chennai, like this. If I have, actually we are expecting 4 columns, but since the data itself contains comma delimiter inside it, we have to consider this entire data as 1 column, but we can't able to do that, because if you look at this data, you'll be considering this data as first column as 1, second column value have inceptors, third column contains the address contains 27, and A is nothing but the city. Like this, we will be considering the data. Hive will consider the data. Rest of the data will be left out. So in order to handle this kind of situation, we have an option in Hive to say, hey, Hive, consider, or the source system, I'll ask and say, hey, put this data in a quoted character. Put the quoted string here. By this way, I'll understand, oh, these are all address. And I'll tell to Hive, hey, Hive, treat the quoted string, which is kept as double quotes or single quote or whatever, and consider that as a entire data set. Don't go and treat this first value in this column value has the address. You treat this everything until the quote is closed. Like this, I can tell to Hive by using some concept called the was, I mean, the CSV study. So let's go and see that exercise. I mean, see the concept, and we'll come back. I'm going to do what? I'm going to call the Hive use case customer payments original file, which you have just created originally, right? You can see here. Originally, what we did is inside this Hive use case folder, we went and got this file downloaded originally, right? So that file, I'm going to load it into a MySQL table. I'm going to invoke the file called Hive use case. It should not be use cases. It should be use case. So I'm going to create a table in the MySQL database level. Why I'm creating the table in a MySQL? I want to scoop this data for that reason. So we are going to learn two things here. So per customer payments or whatever, I'm just going to keep the customer payment information in a customer payments database like this. We are going to create couple of tables by running this SQL script actually. So customer payments is the database. We are going to pull the data called the table called customers table. Okay, so let's see how it works. The customers table, I'm going to pull the data from this database. So this customers table got created and data got loaded into this table if you see here. But whereas if you see in the data itself contains an address or whatever the value, right? You can see the address that contains comma inside it. So we see here, this data has comma inside it, right? 57 comma Rio Royal or something like that, which has comma. So the delimiter is also comma, and inside the column also we have a comma as a delimiter for the address or whatever. That leads to a problem in handling this data. So for that reason, we will be going and loading this data into a special type of whatever the I mean like a SERDI called CSV SERDI. So let's first of all go and import the data from the database called customer payments from the table called customer with number of mappers 2, where we are going to mention predominantly a option called enclosed by option. Enclosed by means what I'm telling, they just keep all the string fields and all can be enclosed by using double quotes. So by that way, what happens, this particular value, whatever the 54 royal Rue Royal or whatever, will be created as an output in the Hadoop location with double quotes placed on top of it. So we can see the output with the double quotes. Let's go and see the data. So I'm telling a enclose the data by using double quotes like this. I'm telling why I'm putting an escape sequence here. I'm telling this is not the starting of a double quotes. This itself is a content I'm going to use. So basically, if you put like this normally in even in a Linux platform, if you do like this, something like if you put a single quote and put double quotes, if I close this single quote, it won't consider. So what I'm telling, A, inside this single quote, for example, A equal to something like this I mentioned. We don't mention an escape sequence. If we do echo $A, it prints the double quotes here. Whereas if I say put an escape sequence, maybe here it is not working as we expected. This escape sequence will be considered as what you know. Let me see in other way. Okay. So if I'm going to put some data in between here, like this, if I'm going to keep, okay, A equal to double quotes I'm going to keep. A is supposed to have double quotes in it. So it is having as like I expected. If I don't keep the escape sequence here, what it will think? The A variable is assigned with null value like this. It will think up with the first double quotes and second double quotes. And it won't allow me to continue here. It will ask me to close this double quotes because it will think like I put a wrong 3 double quotes without closing the third double quotes like this. It will think. So it won't work basically. For that reason, what I'm telling, escape this double quotes, which is supposed to be considered as a data, not as a double quotes that I'm using for closing this first double quotes like this. I'm just using an escape sequence saying like, hey, escaped by the slash, the backslash. But I'm using two escape by saying like why? In the data itself, this escape will be applied. So don't consider that as your data. You just keep this as a escape by statement like this I'm telling, and running the scoop command, you'll see the data, you'll get a clarity here. Okay, we have to see the data for understanding it in a better way. So we have a concept called, or in scoop itself, we have an option called enclosed by option and escaped by option. Enclosed by will be used to put double quotes on the string data, and escaped by will be used for putting a escape sequence on the double quotes to make it more meaningful. So let's go and see that part once the scoop import is completed. We can see the data to understand the concept of what I'm about to speak here. So let's continue on this, like until this data is loaded. I'm creating an external table pointing to this location where in Hive, I'm just going to say use the open CSV SERD. Don't use a normal, maybe like lazy simple SERD. Rather, you use open CSV SERD. By this way, I'm telling what? Use the delimiter as separator as comma and the quoted character as slash double quotes. That means what? The normal separator, the comma, the fields delimited by comma, and the data contains a quoted character like this. You consider this as a maybe like a column quotes, and ignore that column quotes when you are going to refer the data like this. I'm telling here. If you go and see this data, you can get a better clarity. So we got the data imported from the using scoop. So what happened here is maybe even for the number type also it has imported with double quotes. But if you see particularly here, this is more meaningful, right? The company name seems to be having the comma. This is not a comma for separating the columns. It is this says the entire company name is like this. Now we can take this data in a more better way, right? Like this you can consider. Now I'm going to say what? Okay, create a Hive table to consider the quoted character as double quotes like this. I'm telling. So I'm telling, consider this double quotes is not the closure of the first double quotes. It is a data, or it's a expectation of the double quotes over here like this. I'm telling. So let's go and create a table on top of the data what we imported. This time creating an external table on top of this data. So you can see this table will take the data properly now without any issues. Let's consider this data, right? RAN stores, right? 481. So you can see the RAN stores is having comma, which is shown normally. We can able to see the output in a normal way, right? The address also has comma, but it is shown in the contact last name, not address. Some contact last name is shown, and the customer name is also shown without any problem like this, right? Those despite it contains comma as a data inside because it is kept in a quoted character. So why do we use this CSV, open CSV SERD or CSV SERD is to manage these kind of special features, right, in Hive. So we are going to continue this use case not only by stop by saying like, hey, let's treat the data that contains comma in it and all. So you can see here we are just predominantly understanding about the CSV SERD, right? Scoop importing the data and then we are loading it in a CSV SERD table and continuing doing what? We are taking the data from a file system, some other data called payments data in a text file format and load it into a table, joining the maybe like the customer payments table and the maybe like the payments table that we got created. The payments table we are going to load it in an Avro format, and we are going to do some operation of creating the views and all to display only few columns out of the data. What is view? We'll talk about it. Using the view, we can export only the view columns or some of the columns that the view is showing up to the Hadoop file system. So we can use some and then we are going to export the data using scoop into the outside world. So we are going to do some pipeline building over here. This is one part. right? We are reading the data from the customer database table by using the special SERDI called CSV SERDI. Then in the other side, what we are going to do is this is completed. The step number 2 is completed. And three says what? The data what we imported, we are able to realize it. We are able to query it. Now we are taking one more data set called payments data. So in the Hive use case location, we have some data called payment. If you see here, the payments data. This payments data contains who are all the customer made some payment in the business. So customer ID, the check number, the payment date, and the payment amount. Like this, we have 4 columns in this data. So we are going to load this data into the respective table, right? And the table is going to be created as maybe like a Avro table. So we are going to do that operation here. First, we'll create the Hadoop file system location. Then we go and put this payments data in that location. First, we'll do this operation. So we got some data loaded into the maybe whatever the transient zone or whatever. Then we are going to create an external table, namely payments. Okay. So create an external table called customer payments in an Avro format and load the data by doing an inner join of the customer master and the payments table, right? So first of all, we have to create the payments table by referring to the columns. So what you are going to do is create table. That create table statement I did not given. Let me give here. Create external table payments of first NO integer uh, check number, maybe like check number as string. Then we have what other data? So we have customer number, check number, date, check date, and then the amount. Let's go and create a table. So this command, what I'm using here should have the proper single quote. Okay. So you can see I'm creating this table on top of the location where this data got imported. Normally, first we are creating this table. So the requirement here is load the data by joining these tables into maybe Avro file format. That is the requirement. So we got the payments data loaded and it is able to be referred properly. So let's go and okay. Let it be. Now we are going to create one more external table of Avro format, right? And load the data by doing an inner join of both the tables using insert select, by applying all this maybe join condition. So I wanted uh, to load the data from the CSV SERDI joined with the payments table that we created above into a table called customer payments in an Avro format that we have to create. So maybe like I wanted this can be tried by you guys, right? Especially because this is a simple thing what we have already done. So you can just try this out. I don't wanted to talk about it. And on top of the table, the customer payments, whatever we created here, right? Create an external table called customer payments we are creating, right? On top of this customer payments table, I wanted you to create one view. I'll tell you what is a view is all about in general. You can apply the view on top of this customer payments table separately once you create. But for now, I'll show you guys what is a view concept is all about. So view basically is nothing but a stored query. Just we can store a query in a name of a view. So something like this we can create. For example, I don't want it to show the check number, or I don't want to show the check date information to somebody. What I'll do, I'll go and create one view called create view name as payments underscore VW. Select as select. Maybe what are the columns I'll select is Customer, comma, amount. These two column alone I'll be selecting from the payments table. When I do this, what happens? The query called select customer number amount from payments, where maybe like amount greater than maybe 10,000. Only this customer information alone I want to display it in a view. So rather than you write the view query again and again in a later point of time, we can have this query stored in this name. So by this way, what are the benefits we get is later, if I'm going to say, hey, you want to see the payments, how much the customer is supposed to make in our business, if you want to see, you go and query this view. This query, the view will internally run the above query, this query, the select statement, and show you the result in the screen. So the view will help us store the query. This query is entirely stored in the view. When I say select star from this view, it will internally run a query like this. It will internally go and run a query something like this. If you don't know about this concept earlier, the people who are all not from the DB background, try to understand this as a first cut learning, and we'll be learning about the concept of views in the maybe like in the cloud databases and all in a later point of time. By that way, you'll get a lot of benefits out of it. So this is not this name I can give like something like payments view or something like that. You can see like this. This is how it is going to run in the background. So view is nothing but the stored query. View does not contain data. These are all typical interview question asked in the database side. But at least in our big data platform, sometime it may be asked as well. You have to know the purpose of view as well. So what is the purpose of view? Store the query, some complex query in a name of a view. And then by storing the complex query in a view, you don't have to maybe write the queries again and again. Rather, we can reuse that query by simply calling that view. So reducing the complexity of writing query is one of the benefit of creating views. The performance side, when create a view, apply all the performance tuning. Maybe for partition column level filter, we are going to apply. For example, let's assume I'm going to only show the amount greater than 10,000 rupees to the people. Or I'm going to apply some partition based on some column, the date column that we have internally. So we will apply select star from, we'll create another view, something like this payment view. Number one I'm creating, two I'm creating, where I'll mention where amount is greater than or where date is equal to current date. And amount is greater than 10,000. Like this, if I mention, the view got created, right, by passing the current date every time. So whenever the current data alone, if somebody wanted to see, they'll use this view to see the output, but there is no current day data we have available. So because of that reason, the data is not shown here. But however, we can apply if the date column is a partition column in this table, means this query will be running more efficiently. So we don't have to expect the client to mention the view, the partition column. Rather, we itself can keep this partition column as a filter in the view query. By that way, we can improve the performance of maybe like creating views and security. The view will help us maybe like avoid some of the columns which is not supposed to be exposed and some of the rows which is not supposed to be exposed. So here what I'm doing, I'm only showing the customer number in the amount column, not the check number and the check date. And I'm restricting only the customers who are all did a higher transaction or lower transaction, anything you can consider. Low value transaction. Whoever the customer are doing a transaction less than 10,000, only those data I'm showing to the in the view output. So by this way, we can able to improve the security on the data by creating views. These are all the real-time benefits of views we used to use in the organizations. So view is very important concept. I hope you understood by looking into this. Okay, extract only the customer number and all these columns and store the output from the view and store the output into a Hadoop location with the delimiter of pipe. So how do you do that? Try to think about, we can use external table option or we can use some option called insert to override directory option, which we already seen in our Hive hands-on documents, and export the data from the customer payments export location to the MySQL table by using the scoop statement, right, with the records per statement as 100 or number of mapper as 3, which you guys know how to write it as a scoop command. So I wanted to stop here for now, and then I'll cover this use case number 3 and use case number maybe 4 we have, I hope so. And I'll provide you as a very important use cases. I'll provide you as the next video. For now, let's close with this, guys. Thank you.